Okay, so this is being raised to the 1/2 power. I need to get rid of the 1/2 power. So maybe you need to see it as what that really is. Maybe you need to see it like that. But hopefully you know that if you square this, 1/2 times 2 is what? 1. So everything is to the first power. But whatever you do on one side, you have to do on the other. So this really just becomes x minus 3 equals, well, 5 squared is 25. So do you see that this is the same thing as this? The x minus 3 in parentheses to the 1/2 power is the same thing as the square root of x minus 3. I want you to write it however your brain processes it best, okay? Still trying to solve for x. How do I get x all by itself? Add 3 to both sides. Yeah. So x equals 28. I need to check that. So I'm going to go to my original equation. So my original equation, parenthesis 28 minus 3, close my parenthesis, to the 1/2 power equals 5. Well, let's see. 28 minus 3 is 25. And 25 to the 1/2 power is the same thing as the square root of 25. And that does, in fact, equal 5. Dylan, take notes. Close your keyboard. Are you writing notes? Okay. C. Are we ready for C? Am I going too fast? Is this making sense so far? A little bit? Okay. C. I need to get rid of the square root symbol. How do I cancel out a square root or an exponent of 1/2? I have to square it. But whatever I do on one side, I have to do on the other. So when I square that, the radical symbol goes away and I'm left with 2x minus 1 equals, let's see, 4 squared is 16. Trying to solve for x, what should I do first? Plus 1 on both sides. 2x equals 17. Last step, divide both sides by x equals 8.5. That's the first time I've had a decimal. Let's see. Let's check it. Let's put it into our original equation. The square root of 2 times 8.5 minus 1, that's all underneath the radical symbol, equals 4. Well, what is 2 times 8.5? Well, it's 17. 17 minus 1 is under the radical symbol, equals 4. Well, what is 17 minus 1? 16. And does the square root of 16 equal 4? Yes, it does. How do we feel about that? Okay. I want everyone to look at example D. And I want to talk about how you perceive this question. So what does this question look like in your brain? How do you think of this? Do you think of that x to the 1/2 power as a square root? Does that make it better for you to process? Yeah? So can I tell you what this really means? This means 3 times the square root of x minus 4 equals 20. Does that look better for you? Okay. So I'm trying to get x all by itself, but the first thing I have to do is undo any addition or subtraction, right? So what do I have to do first? What is the addition or, yeah, I have to add 4 to both sides. Oh, did she? Okay, I didn't hear you, Haley. I'm sorry. Thanks for giving her props. So 3 times the square root of x equals 24. I'm trying to get the square root of x all by itself, but it's got a 3 outside of it, 3 times the square root of x. What's the undo of multiply? Divide. So now I have the square root of x equals 8. How do I get rid of that square root symbol? What'd you say? Square it, yeah. So the square root of x squared is just x, and that says that x equals 64. We definitely need to check that one. We definitely need to check that one. So let's see. Check. 3 times. I'm going to plug it in as the square root of 64 instead of the 64 to the 1/2. I'm going to write it as the square root like we rewrote it. Minus 4 equals 20. Well, what is the square root of 64? So I really have 3 times 8 minus 4 equals 20. What is 3 times 8? 24 minus 4 equals 20. And what is 24 minus 4? Yeah, does 20 equal 20? Yeah. How do you feel about that? Does that make sense? Okay, flip over because we have E, F, and H. G I didn't do because it's the same thing as that we've been doing, really. But H is special. So let's look at E. Let's look at E. Well, what do I have to do to get that square root all by itself first? What are the steps I have to do to get the square root all by itself? Subtract 7. Good job, Dakota. So 2 times the square root of x plus 5 equals, let's see, 13 minus 7 is 6. Okay, next step. I have that 2 outside of it. That says 2 times. Divide by 2 first. You want to get it totally, you want to get that radical symbol all by itself. So when I divide both sides by 2, I have the square root of x plus 5 equals 3. And now what do you want to do? Square both sides. So when I square that, the radical symbol disappears and I have x plus 5 equals 9. Yeah. Subtract 5. X equals 4. I think we need to check that. So 2 times the square root of 4 plus 5 plus 7 outside of the radical equals 13. Well, what is 2 plus, or sorry. What is 4 plus 5? 9. So I have 2 times the square root of 9 plus 7 equals 13. What is the square root of 9? So I really have 2 times 3 plus 7 equals 13. What is 2 times 3? So I have 6 plus 7 equals 13. What is 6 plus 7? How do you guys feel about that? Are we okay with that? Okay. You're going to do F. I'm going to freeze the screen. You're going to do F. Okay? Do F on your own. Tell me when you're ready. Yeah.
So it's 3x right here.
Yep. Yep. So you're going to add 2 to both sides. Keep going. You got it. Keep going. You right on the money, bud. I see your hand. I'm coming right over. Dang it. Trying to do the check and it just kicked me right out. What do you got, Dakota? Do that first. Then you do it. You have to square it first. Square it to get rid of it. Perfect. We ready to see it? You guys want another minute? 1 more minute? Okay. Yeah, it's kind of cool. I think this is like when stuff is starting to get fun. Yeah, I will. Will you get up here and finish doing my check? Aubrey, come and finish doing my check. I'm at 3 times 22 underneath the radical. You got it. Just, yep, check it. Perfect. Are you serious? Yeah. I got it. Yeah. That was fast. Okay, here we go. I'm going to throw it up there and you guys can see it. So I got x equals 22. I'm doing the check right now. 5 times, let's see, this is 3 times 22 is 66 minus 2 under the radical minus 4 outside of the radical equals 36. 5 times 66 minus 2 is 64. Minus 4 equals 36. Square root of 64 is 8. 5 times 8 minus 4 equals 36. 5 times 8 is 40. 40 minus 4 is 36. So your answer should have been x equals 22. I love that. I love it that you guys are feeling confident about that. We're just going to do h, and it's in such a teeny little tiny spot for me. I'm going to try and squeeze it in here, but it's going to be fast, so I should be able to get the work in here. So when I do h, the first thing I have to do to get the radical symbol by itself is subtract 9. So I get the square root of 3x plus 5 equals negative 9. When does the square root of anything equal a negative number? Well, only when there's a negative out front of it, right? Or if it says plus or minus in front of it. So can the square root of that equal the negative? We didn't draw the square root, it was already there. The square root symbol was already there. There's no plus or minus out in front of that radical. Is it possible for 3x plus 5 to equal negative 9? No, it's not. There's no real solution for that. We're not doing a quadratic. There's no real solution for this, okay? So this has no real solution, okay? Now I'm going to jump down to the example number 2, and then we'll do three on the back side. So page 20. So this is really cool because probably you forgot about this, but you also graphed stuff like this in Math 1. So I'm going to just focus on this square root equation really fast. If I want to graph this, let's see. If I think about my values of x, I'm going to make a quick table of values. If x is negative 3, what is the value of y? Well, negative 3 plus 3 is negative 3 plus 3 is 0, and the square root of 0 is 0. If I were to let x equal negative 4, just hear me out for a second. If x equals negative 4, I would say that y equals the square root of negative 1. Can we graph that? No, we don't know how to graph imaginary numbers. Like, we don't do that. So that's why our range has to be, or your domain values have to be greater than or equal to negative 3. So let's think of another number, because I only want perfect square answers. So if I let x equal negative 2, what's negative 2 plus 3? 1. And the square root of 1 is 1. Okay. Let's see. My next perfect square would be 4. So how am I going to make, what x value would give this underneath the radical a 4? What value of x can I input that would make this the square root of 4? Because I want perfect squares under the radical. If I let x equal what, will I get a 4 underneath the radical? X plus 3 equals 4. What number plus 3 gives me 4? 1. So if I let x equal 1, I get the square root of 1 plus 3, which is the square root of 4, and that's a nice number. I'm trying to pick nice numbers that we can graph it, right? So the next perfect square is, what comes after 4? 9. What do I have to add to 3 to make it equal 9? 6. So I have to let x equal 6. 6 plus 3 is 9. The square root of 9 is 3. So I want to show you what that looks like right here. I'm going to let x equal negative 1, 2, 3. When x is negative 3, y is 0. When x is negative 2, y is 1. When x is positive 1, y is 2. And when x is positive 6, 1, 2, 3, 4, 5, 6, y is 3. So this graph looks like this. It's a curve that goes just like that. The other equation is a linear equation. And you guys know how to graph a linear equation. That's written in the form y equals mx plus b. B is where I begin on the y-axis, which is at positive what? 1. And what is my slope? Do I need to talk about this really fast? Y equals x plus 1. This is the b value, the y-intercept where I begin, positive 1. And this is my slope. There's no number attached to the x, so that means that my slope is 1. That means I go up 1 over 1, up 1 over 1. And I'm going to continue that pattern. Or I go down 1 to the left 1. This is a system. This is a system of equations. One is linear and one is radical. Okay? The curved one, yeah. Yeah, the curved one is the radical one. And I'll even tell you what it is. This is y equals the square root of x plus 3. And this is the equation y equals x plus 1. So think about when you learned about systems, where those two lines, where those two graphs intersect, that is the what? That is called the, where the two lines, where the two graphs intersect, the point where the two graphs meet is called the what? It's the solution. The solution to the system. The solution is the ordered pair 1, 2. What does that solution mean? What does the solution mean? Well, the word solution means that it's going to work for both. It means that the ordered pair 1, 2 works for both equations. Okay? So when we graph it, we get the solution 1, 2. That's what the graph says. It's right there. I highlighted it in red. That's our solution. Now let's try and solve it algebraically using a method that we both know. Y equals the square root of x plus 3. That's the first equation. And the other equation is y equals x plus 1. Well, hopefully you remember this dirty word right here, substitution. You guys see that it says y equals this and y equals this. So if y equals the square root of x plus 3 and y equals x plus 1, then these two things have to equal each other. Do you remember that from substitution? So I have the square root of x plus 3 equals x plus 1. How do I solve this? One side is a radical side, the other side is a linear side. I have a square root expression and a linear expression. Well, I still have to get rid of the square root. Square both sides. Uh-oh, I'm squaring a binomial. Do not make any silly math mistakes. So x plus 3 equals, what does this look like when you square it? X plus 1 times x plus 1. It just means repeat multiplication, right? So I have to FOIL. X times x is x squared. 1x plus 1x is 2x. 1 times 1 is 1. Now what? I'm trying to get x all by itself, and this is a quadratic, so what do I have to do to solve it? Set the whole equation equal to 0. So I'm going to subtract x and 3 from both sides. Minus x minus 3. So I have 0 equals x squared. 2x minus 1x is 1x. 1 minus 3 is negative 2. I'm going to factor this using the AC method. A times C, negative 2, adds up to a positive 1. What two numbers can I multiply together that give me a negative 2, that when I add them, I get a positive 1? Multiply to give me negative 2. When I add them, I get a positive 1. Well, the only two numbers that you can multiply together to get 2 is 2 times 1. One of these needs to be negative. A 1. What's the value of A, your leading coefficient? When A is 1, the factors that you choose are the factors that you, so this becomes x plus 2 times x minus 1 equals 0. Well, if x plus 2 equals 0, what is the root or the solution? X equals negative 2. And if x minus 1 equals 0, what is the root or the solution? Positive 1. So when we solve it algebraically, we get the ordered pair negative 2, x equals negative 2 something, and x equals 1 something. Well, we know that when x is 1, y is 2. We know that when x is 1, y is 2. We know that from our graph. But when x is negative 2, y equals positive 1 on the square root equation and negative 1 on the linear equation. Do you see how they don't line up? Do you see how the solutions don't line up? So why does your answer from part A contradict what you found in part B? Well, in example B, x cannot equal negative 2 because you get two different answers. You get negative 2 comma 1 and negative 2 comma negative 1, and that's not possible. Okay, so that's why. We're going to do 3 more. I know what time it is. We're going to do 3 more. So flip it over. We'll do A. We'll do A on the front, and then we'll do example. Actually, let's do B on the front. B is harder. We're going to do B on the front, and then we'll do 7 and 9. B, 7 and 9. So let's look at example B. I have to, when you solve equations that have both linear and radical, right? Linear and square roots, you have to get the square root all by itself. So you have to get rid of that negative 2. You have to move that negative 2 over and then get rid of the radical. So how are we going to do that? What's the steps that we're going to use? How do I get rid of this negative 2? How do I move it to the other side? add 2. So I have 2x plus 2 equals the square root of x plus 6. How do I get rid of that radical square root symbol? Square. Whatever I do to one side, I have to do to the other. So the right side, x plus 6 equals, do not forget what it means to square a binomial. You have to FOIL that. Don't come at me and tell me that that equals 4x plus 4. Let's see. 2x times 2x is 4x squared. 2x times 2 is 4x. 2 times 2x, 4x. 2 times 2, 4 equals x plus 6. Combine your like terms. 4x squared plus 8x plus 4 equals x plus 6. What are we going to do next? It's a quadratic. I have to set it equal to 0. Subtract x from both sides. And what else? And minus 6 from both sides. 4x squared. 8x minus 1x is a positive 7x. 4 minus 6 is a negative 2 equals 0. Do you guys want me to use the A times C method or the quadratic formula? Quadratic formula. A, B, and C. Quadratic formula, opposite of B, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. All right, I'm going to do some mad simplifying. Negative 7 plus or minus the square root of 49 plus, this is a negative times a negative is a positive. So 16 and 2 times 2 is 32. 49 plus 32 is 49 plus 32 is 81. Thank you. Over 8. What is the square root of 81? It's 9. So I have negative 7 plus or minus 9 over 8. Remember, that gets broken up into two things. That means negative 7 plus 9 divided by 8 and negative 7 minus 9 divided by 8. Negative 7 plus 9 is 2. 2 over 8 is the same thing as 1/4. Negative 7 minus 9 is negative 16. Negative 16 over 8 is negative 2. We have to check. That's why I'm skipping the first one. So we're going to do the check right here on this side. So my solutions are 1/4 and negative 2. Because one of these answers isn't going to work. A lot of times when you have a linear and a quadratic equation written together, you have what's called extraneous solutions. So let's try the 1/4. 2 times 1/4 equals the square root of 1/4 plus 6 minus 2. 2 times 1/4 is 1/2 equals 6 plus 1/4 is 6.25 minus 2. Someone take the square root of 6.25. Quickly, quickly. Yeah, 2.5. What is 2.5 minus 2? It's 0.5. Is 1/2 and 0.5 the same thing? Basically, totally. Yes. So this one works. This is good. Now we got to check the negative 2. 2 times x is negative 2 equals the square root of negative 2 plus 6 minus 2. Let's see. 2 times negative 2, that's negative 4, equals the square root of negative 2 plus 6 is 4, minus 2 on the outside. The square root of 4 is what? 2. What is 2 minus 2? Negative 4 does not equal 0. This solution right here is called extraneous. It's called extraneous. Okay, does not work. Do you want to do, do you want to do 9 or 10? 9 or 10? Okay, 9. You guys don't have anything like this on your homework, I don't believe. Let's go to 9. This just says radical equals a radical. How do I get rid of that? Square both sides. Yeah, this is quick. We're going to square both sides. When I do that, I end up with 5x minus 11 equals 2x plus 16. Minus 2x minus 2x plus 11 plus 11. 5x minus 2x is 3x. 11 and 16 equals 27. Divide both sides by 3. X equals 9. Let's check that. We have the square root of 5 times 9 is 45 minus 11 equals the square root of 2 times 9 is 18 plus 16. What is 45 minus 11? And what is 18 plus 16? 34. Square root of 34 equals the square root of 34. Okay. If you were looking at example 10, you would have to get both radicals, cubics, whatever on, you have to get them each on one on each side of the equal sign. So you really have the cube root of 3x plus 7 equals the cube root of x. How would you get rid of that cube root? Not square it, but cube it. Yeah, you would cube both sides. 3x plus 7 equals x. Minus 3x. 7 equals negative 2x. Divide by negative 2. Negative 3.5 equals x. And you can check it. It works. Negative 3.5 equals x. Okay. So I'm going to go back to the module really fast, and then I'll do as many delta maths as I can in 10 minutes.